The feature you are about to watch contains scenes of a graphic nature. If you find the sight of RetroTech suffering upsetting, please hide behind a sofa now. Thank you.
One day, I was minding my own business when this happened.
Right, putting out the cry for help. Any ideas? Got this? Non-functioning, chips missing, found the ULA had been removed and put back with the pin out, which got me this far.
I find this kind of thing hard to resist. Initially, I offered James advice on how best to diagnose and repair a broken ZX Spectrum. At the time, I had no idea this was no ordinary broken ZX Spectrum. As James wasn't getting anywhere with his repair effort, I offered to take a look and he agreed to send it to me. Through the magic of Twitter direct messaging, James told me the story of how he'd rescued this Spectrum from the hands of someone literally in the process of binning it. My imagination insists there was a scuffle, blows were exchanged, and James emerged triumphant with the poor rubber-keyed hero clutched in his hands, and probably a bloody lip. If you give YouTube a search for ZX Spectrum repair, you'll find a multitude of superb videos from many excellent channels. I should know. I've watched them all. And if you were to watch all of those videos, you'd learn of the many ways a 48K Sinclair ZX Spectrum can go faulty. It's always the RAM, says the frankly delicious Sir Johnny of Reenthused. This is more often than not correct. Other common failures can be a fried transistor, a toasted ULA, fricasseed CPU, and barbecued RAM. RAM got another bonus mention because it's always the RAM. Thank you, Johnny. Usually, your standard broken Specky will contain one of these faults, sometimes two. This can make for an interesting repair, but I can say honestly, here and now, hand on heart, I've never seen, and I expect never to see again, a ZX Spectrum with as many faults as this one. And here it is, saved from the bin and oblivion. Toy Story 3 springs to mind. I'm not crying, you are. The beaten and worn case shows this was once dearly loved, which is another way of saying it's knackered. Removing the screws, I discover one of them is missing its threads. That's a blank before the threads are cut during manufacturing, and while I'm not surprised it was here in the first place, I'm more than a little surprised it was taken out and put back in by multiple owners. Not sure if the splodge of white paint over the ZX Spectrum emboss is deliberate or someone just spilt Tipex on it. No key mat or membrane. Those will be ordered if and when we know this can be saved. And here we are. This is an issue 2 48K Spectrum, easily identified by the heatsink on the voltage regulator being in the front right corner rather than across the back. Another dead giveaway is where it has issue 2 printed on the bottom edge there. A first glance tour of the inside to familiarise ourselves, or yourselves, I already know where everything is. Starting at the top right, we have the ROM, which in this case is soldered directly to the board. That can be a good sign and could mean it's not been worked on before. Foreshadowing. Next is the Z80 CPU. On top of the CPU sculpts a transistor, commonly known as the spider mod. Obviously, facehuggers hadn't been invented then. Another bad sign is, what the hell is that? Okay, so the CPU has had its spider mod transistor soldered back on top while still in the socket. Those two legs aren't supposed to be touching. I'm not sure the person who did this really understood how electricity works. Okay, moving on. This group of chips here are LS147 logic chips. They control the flow of data to and from the lower and upper RAM. IC3 and 4 here deal with the lower RAM, and the other 4 control the upper RAM. IC3 and 4 being in sockets is unusual. To the left is the ULA, the beating heart of the ZX Spectrum and the most expensive single part of the computer, barring the case. A socket is expected and present. The LM1889N chip deals with the video signal before it's passed to the RF modulator. No socket here, it's not often these fail. The upper RAM is here, and we can see work has happened here too, with 3 of the 8 chips in sockets. Finally, the lower RAM here. Again, 3 chips in sockets. This first glance gives a strong impression someone has been here and done stuff. Something worthy of note on some issue 2 boards is a complete lack of coating over the top traces. A modern circuit board will be coated top and bottom with solder mask. These uncovered traces are prone to damage and bridges, something which will come back and bite me later. Before turning on a new to me Spectrum for the first time, I always run through the Joule Coulomb recommended tests. I'm not an authority or expert on this, or the pronunciation of Joule Coulomb. So if you'd like to know more, how to, and why this works, I suggest checking out the Initial Checks video on his channel. The back of this board is, well, there's no kind way to put this. It's a mess. James explained he'd reflowed some of the joints in an attempt to repair, and that originally it'd been in a worse state. Shall we talk about the orange bodge wire? Nah, let's put our fingers in our ears and pretend it doesn't exist for now. It's probably not important anyway. La 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 la. Cursory inspection completed. It's time to switch on and find out where we stand. Broken. Yep, definitely broken. This is where we stand. The current draw is a bit low for an issue 2, but a later revision, more efficient ULA could be accounting for that. Time to check voltages. First, the incoming 9 volts and outgoing 5 volts on the regulator. Then the lower RAM. 5 volts is good. 12 volts is also good. Minus 5 volts is fine. I popped the ULA and tested it in a spare working issue 2. It works fine. At the time, this came as a relief, but spoiler alert, during the repair, this went faulty and had to be replaced. Off camera, I also checked the socketed RAM and logic chips, and they were all good too. With the easy tests out of the way, it was time to inspect the board, looking for trouble. I found trouble in the form of a grotty transistor laying on top of the CPU, like an ugly carbuncle. These 2 legs shouldn't be touching, and after testing for resistance, it turns out, despite all appearances, they're not. Well, not electrically. And it's not because of clever wire management, more down to excessive corrosion. This is, of course, the infamous spider mod. This transistor is incorporated into the motherboard in later revisions. Now, normally, if you socket the CPU and want to keep the spider mod on top, you would solder the transistor to the CPU before inserting it into the soft plastic melty socket. If you don't do it that way, well, this kind of thing happens. There is an alternative location avoiding all this anyway. I'll get to that later. Great. The solder has welded the CPU to the socket. This socket needs to come out. Who knows what might be hiding beneath?
Soldered it in place.
Using some braid, I soak up as much of the solder as possible before attempting to remove the chip. It's still stuck very firmly in there, so I heat a leg at a time while levering from each end, and eventually it comes free. You can see how far down the legs the solder flowed. Being from the future, I can tell you now this is the best bit of soldering the previous repairer managed on the entire board. Let's get those legs cleaned up so I can test it in another machine. Blue tack is my third hand again. A light pass with the fiberglass pencil to remove the final dregs. This 4S board is in good working order. Removing the heatsink will give me better access to the CPU socket. I've other Spectrums here, but this is the only one that currently has a socketed CPU. In goes the CPU from the issue 2, and it tests fine. Here's another issue 2 with the spider mod in the alternate position. This is a factory mod, and I'll be copying it to the poorly Spectrum. The usual transistor is a ZTX 313. Both the Zombie Specky and this pristine issue 2 have ZTX 312s. I looked up the differences and it seemed they're very similar. I have another issue 2 with ZTX 313, so either should be fine.
This is crusty as my fingers.
Which is a good thing, as I don't think this will survive the procedure. But before the spider mod happens, I need to remove the destroyed socket. Hold on a second. Futurely again. I'd like to point to the damage on the surrounding traces here, here, and, well, everywhere really. And if I could draw your attention to this trace, well, technically it's 2 traces now. Does it work like worms? Actually, I don't think even worms work that way. Don't look at the orange thing. Fingers in your ears, everyone. La 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 la. A dab of fresh solder to improve thermal conductivity. The flux in the new solder will also remove oxidization. There's definitely a trick to using the desoldering gun. The first 3 pins here all clear out fine. You can hear from the tone of the moo. When it isn't sucking through a cleared hole, the moo becomes higher pitched. If you listen here on the 4th hole. Sometimes this means the hole is still blocked. Maybe I didn't heat it for long enough, and sometimes it means the gun is blocked. I can tell you it's not the gun in this case, as the moo drops back down to the normal moo level when I remove the nozzle from the board and the trigger is still engaged. This time, with the nozzle off the board, you can hear the moo remains at the higher distressed cow level. This means it's blocked. Normally, a quick poke down the barrel with the right prodding tool will remove the blockage. Sometimes you need to remove the glass waste solder collector and manually remove the block from the coldish end of the pipe. Very often I can wiggle it free with a pair of long-nose pliers. If it's really wedged in tight, I'll need to get the soldering iron in there and melt it away. I've shown this in detail here at the start to spare you pain later on. During the course of this repair, I remove every single chip. Huh? Yes, even that one. From this point, you'll only see brief clips of desoldering. You can thank me later. Once all the solder is removed and the legs pass the wiggle test, the socket comes free without fuss. I can't see me recycling this into another machine. There's a couple of areas of damage. On the top side, this track here is broken just before pin 2. This is the one that had the big solder blob on top. The wire is also damaged and will need some attention. That is where the end of the wire running to the spider mod is soldered to the board. Doesn't look too healthy. At least some of the wire was exposed. Foreshadowing. A few pads are damaged underneath, nothing too bad. As long as there's something to solder to, it'll be fine. Remember this trace? Yep, that's toast. With a note made of the damaged parts, I can repair most of them on the other side. I've chosen to repair this one on top with a small length of kynar wire running from the pad beneath and attached to the trace on top. Should end up pretty much the same as an actual trace. Flux to burn off oxidization. I'm using broad tweezers to hold it in place so I don't brand my fingertips. Another length of kynar through the same hole to join to the trace on the other side, and chop short on the back ready for the socket pin to come through. As I fit the socket in the holes, there's no resistance with the pin fitting into the damaged area.
No pressure.
You can see the extra wires poking through over here. Just to be extra sure, and to avoid bridges onto the exposed traces nearby, I twist the budge wire around the pin. It ends up being a fairly invisible fix. At this point, I had no idea what was coming up ahead, so trying to keep things neat and tidy was still a priority. This trace connects to a pad on the edge connector. You can see here I added a small length of wire to repair the brake. I'm still going to ignore the orange wire. Who knows, it might be the only thing working on this system. Ew. Anyway, the purpose of the spider mod is to correctly handle port decoding, whatever that means. I've found that the effect of not having a spider mod in place is poor compatibility with various revisions of the ULA. The transistor didn't survive having its legs straightened. Oh well, I've plenty of spare 313s anyway. Here's another issue too in my collection with the spider mod in place, and you can clearly see this one is a 313. That's factory. Clever use of green earth sleeving to insulate the legs. As the CPU is now socketed on this board, the wire that connects to pin 30 needs to be routed to the other side of the board. This 30 gauge kynar wire is thin enough to pass through a handy open via. One leg of the ZTX 313 needs to be connected to this pad. The other to resistor R27's left side, and the third to the wire from the CPU. It always amazes me how oblivious I can be to something that seems, in hindsight, so obvious. Have you spotted it? I'm not an expert at working out resistance values from colour codes, but I'm quite certain brown and crispy isn't on the chart. I do spot this sometime later in the saga that this turned out to be, and I can put your minds at rest. That resistor is actually still a resistor and not barbecue charcoal. I end up replacing it anyway. Transistor connected to the relevant places and spider mod reinstated. Has this fixed it? No. I didn't expect it was going to be that easy. I also didn't expect it was going to turn out quite the way it did. So I could make use of my Retrolium diagnostic ROM, I thought it would be a good idea to fit a socket. As we saw earlier with this disgusting orange bodge wire, previous work has taken place here. The bodge wire needs to come off before we can remove the ROM. I switched on my soldering iron, but before I even touched it with heat, I managed to knock one end off the board.
Interesting.
The wire it was attached to still had its solder mask intact.
Oh my god.
Solder mask designed to stop solder from sticking. There's a small chance they managed to make the solder flow down into the wire.
It wasn't even attached.
It'd be an unreliable connection at best. After mooing all of the solder out, I found the other end of the wire hid a missing pad. Again, plenty of minor damage, but this time no broken traces. The hole with the missing pad is below this leg. Looks like more damage here. Fingers crossed it doesn't extend under the chip.
Oh my word.
Okay, everyone calm down please. It can't be that bad. Let's take a look here. This pad on pin 1 is... well, it doesn't exist. It's so obliterated I can't even tell if it's missing a trace. Pin 22 has gone the same way. And this tail coming off this wire is meant to be connected to pin 22. This is what the orange wire was trying to repair. 21. Let's talk about pin 21. At first glance, it seems to be a repair of the trace. There's a little extra solder on the trace below that passes under the ROM here too. But 21 must be in a terrible state under that fix. Small side note here. Something I spotted and sorted later was this glass encapsulated capacitor. These are beautiful things. Which is currently crushed to the board, possibly shorting out on the trace below. Carry on. 21. Actually, let's put a quick pin in 21 and test the ROM. Perfect. All the major ICs on this board are functional. Back to the mess. Solder braid will slurp up the worst of it. The idea is to remove any bodges and make a better job of the repairs. Ah, as I thought, a piece of wire larger than I'd use has been soldered along the top of this trace to repair a break. Seems reasonable if sloppily executed.
Why is that not moving? Has that been glued on?
What the hell?
What the hell?
That's what I said.
What the actual... Okay.
More solder braid? There must be a break that's bridged by the old solder. Ah, right. Okay. That trace there, the one that runs to pin 21, that's actually fine. It's a little tatty around the edges, probably from some ape soldering a bodge wire onto the top of it with a blowtorch, but otherwise it's fine. Why the Herbert that did this felt the need to repair a perfectly good trace is a mystery.
These are all fine.
I'll warn you now, there's more of this to come. On with the repairs. I decided to repair this on the top side of the board. It'd probably be better on the other side, but as there was literally nothing to solder pin 22 onto, I thought I'd run the bodge over the top and down into the hole where it could be attached to the socket. It looked neater that way. Off camera, I filed a small channel on the base of the socket to allow it to sit flush to the board over the top of the wire. This pad here has a broken trace. To give it a little more strength, I twisted some kynar around the pin and then soldered it to the end of the trace. Another neat and tidy repair. But did any of this make any difference? Nope. I had now repaired damage under the CPU and the ROM. The ULA comes socketed from the factory, so I'd no reason to suspect it was damaged. Foreshadowing. That left the RAM, logic chips and passives. Before I could start tearing out RAM chips, I spotted a problem.
Look at that.
This is capacitor C45, which lives to the right of the lower RAM at the bottom of the board.
What is that?
And that, well, I don't know what that is.
And why?
Or why it's there. Here's another issue too, showing off the same area. And here is the... I don't even know what to call this anymore. I'll think of something. That bit there, that shouldn't be there. Maybe it was put there deliberately to repair a broken trace. Incidentally, the trace running from this end of the capacitor is missing. Is this an attempted repair of that trace? Looks like they threw it onto the board from a distance, with their back turned, blindfolded. I'll hand you over to Lively, our man at the scene.
So, C45 minus leg is connected to ground. Okay. Sorry I didn't show you the removal of C45 on this one. Not very exciting. But there's the pad. What's left of it? No ground. It's not connected. For some reason, there's a bodge in there that doesn't go anywhere.
Let's get the cap out of the way. I think this was installed using the corkscrew method.
Wow.
Right, hold it there. Let's work out what's going on here. These blobs of solder along this trace and this one must mean damage was done and these are repairs, yes? Let's not forget what was under the ROM. This is... I don't know what this is. Probably shrapnel.
There's a lot going on there.
What's it connected to? There's an intermittent connection there and it moved. Shrapnel then. A dropped component leg got accidentally soldered in place with a large amount of solder underneath a capacitor. Was this repaired in the dark? How about the solder along those thick traces? Another cut-off component leg which was laying along this thick trace with solder over the top. I have no words. Surely it was put there to repair a break. No! It was put there by accident. The only actual damage here is the missing ground trace between these 2 points. I tell you, blowtorch. And just while testing, I replaced the original capacitor in C44 and put a new radial capacitor into C45 using alternate nearby holes.
That should be connected to that. That should be connected to that. They should be connected to each other.
So, did removing the debris bodge and repairing the broken connection fix anything?
Go on, work. I dare you. Oh, I need to be on.
No.
Still the same. It's the RAM. Gotta take out the RAM.
Oh, where's the RAM? Look, as much as I would love to show you the whole repair in a single episode, I'm not sure a 2-hour video will be appealing to many people. So I'm going to cut you off there. You'll have to speculate amongst yourselves how much worse it could possibly get. In the meantime, why not come say hi to me on Twitter? You can find my Twitter link in the description below, along with a few other relevant bits of information. And before I say farewell, I don't normally remind people to subscribe and click things. You're grown-ups, according to the Twitter stats. You can make your own minds up. But I'm closing on one of the first big milestones in a YouTube channel's journey. Why not get in with the cool pre-1K crowd? Or don't. I'm not your mum. Don't miss the next exciting instalment of this repair, though. That would be a real shame after you watched all the way to this rambling point. Bye!